Hi, everyone, and welcome to our webinar. Thank you for taking the time to join us today. My name is Elisabeth. I'm the head of Systems Integration Department at Ekin Company, which is a trust service provider, implements digital identification solutions and related intelligent projects. These minutes of my talk are devoted to promoting AI for building, maintaining, and scaling intelligent enterprises. Artificial or machine intelligence, as the experts in the field suggest, simulates human behavior or thinking, and besides solving complex problems in multiple industries, makes our daily life more comfortable and accurate. The following topics outline the presentation: benefits of embedding AI in organizations, brief introduction to AI types, subsets, and applications to get insight of AI in general, steps for shifting to AI in order to build intelligent organizations. Then we will explore best practices of scaling AI for business management, business data analytics, software engineering, and cybersecurity. These four domains are essential as they discover and address every digital industry needs. Key takeaways will summarize the presentation. AI is a next generation progression. It leads to step-by-step automation and orchestration of various complex operations by embedding algorithms and tools of proven reliability and required accuracy. AI algorithms are designed by humans, but unlike humans, AI outcomes can be permanently verified and optimized according to customers' feedback. Humans are error-prone. We know workers will make mistakes. However, we don't know what the mistakes will be. People even make the same mistake despite awareness and training, and this makes people the weakest link in every organization. This slide presents a non-exhaustive list of benefits of embedding AI in digital companies and mitigating human factor. AI systems are available 24/7 and can be accessed whenever required at a given time. AI-enabled computers make zero errors if programmed correctly. AI-enabled digital assistants help in addressing routine and simple customer queries. AI applications can be used in the areas which are hazardous to humans, such as area surveillance, sea and cosmic space exploration, rescue operations during natural disasters, and so on. AI makes healthcare operations more efficient. Healthcare workers spend a lot of time doing paperwork and other administrative tasks. Generative AI can help clinicians with note-taking and content summarization. AI provides opportunities to help reduce human error, assist medical professionals and staff, and provide patient services 24/7. As AI tools continue to develop, there is potential to use AI in reading medical images, X-rays, and scans, diagnosing medical problems, and creating treatment plans. AI algorithms can facilitate the rapid analysis of health data, leading to precise diagnosis and timely interventions. Predictive models powered by AI can detect patterns and trends, aiding disease prevention and personalized treatment plans while preserving the patient's privacy and data confidentiality. AI can help detect frauds in every document flow and recognize unusual or suspicious patterns in insurance claims. AI has revolutionized the field of astronomy by enabling efficient analysis of vast amount of data, automating the identification of celestial objects, aiding in the discovery of exoplanets, and facilitating the study of transient cosmic events. AI automates repetitive tasks and processes such as data collection, data entry, email responses, software testing, invoice generation, and many more helps. Employees get more time to focus on tasks which require human abilities. Nowadays, AI-powered data analytics helps to support the business management process. Detection and prevention of network persistent attacks are performed by embedding intelligent software. No humans are capable to fully monitor the network traffic days and nights. As we see, the list of industries where AI can be embedded and empowered is infinite. Willingness and readiness for digital transformation is the first step by which companies can scale AI across their businesses to drive fundamental change and stay competitive. If you compare human intelligence versus artificial intelligence through the prism of key indicators, we will reveal fantastic things. Human intelligence adapts to different environments through a combination of cognitive processes. Humans engage with others and form a dependent cluster of social relationships. Meanwhile, the nature of AI is characterized by codes designed to emulate human intelligence and behavior. When it comes to solving problems, AI is highly equipped to recognize and solve issues instantaneously. Meanwhile, due to the nature of human intelligence, it takes time to acclimatize itself to the changing situations, eventually adapting to them. Human intelligence is proficient at abstract thinking. Also, emotions interact with logic to drive conclusions. Use of logical implication is important when determining how a system processes data and generates responses when inquiries are introduced. When designing a system, it is important to identify logical operations to best arrive at decision points. The way the system handles its duties usually means decisions are being made. The compound statement of the form, if this, then that, implies a decision point in the decision-making process. We notice that human nature is tolerant toward violating conditions for some reason, as we see on the third entry of the truth table of the implication operator. False implies true. This may be for handling maybe some exception or a force majeure. Now, if we come back to machine intelligence, AI lacks the ability to perform abstract thinking. This prevents robots from generating, changing, or following opinions on any specific issue. For instance, self-driving cars learn from unsupervised learning and reinforcement learning methods and utilize encoded value systems, whereas humans collect memories of driving experiences and from the lessons learned. Processing speed of human brain is about 1 million operations per second. AI processing speed reaches thousands of trillion operations per second. Functionality is also important. People utilize the brain's processing power, memory, intuition, experimental knowledge, and other cognitive talents to think and act. AI-powered devices depend solely on data, algorithms, and specific instructions to generate results. AI algorithms can detect factual errors, inconsistencies, and biases infinitely long time without fatigue, ensuring more accurate and trustworthy information, whereas humans often get overwhelmed and urged to sleep and still may not feel refreshed after the rest of sleep. And in philosophy and science, free will also is a concept. It is a supposed power of capacity of humans to make decisions or perform actions independently of any prior event or state of the universe. AI systems are programmed, which means they do not have any other options. They cannot step outside of the system and decide against the algorithms it had been embedded, and hence do not have free will. However, construction of conscious computing agents is a step toward artificial intelligent beings' development. AI is full of algorithms and mathematical calculations, which, when realized, will help the developers in selection of approaches, methodologies, and technologies to leverage AI in organizations. Computer science, math, engineering, and other related disciplines are all combined in AI. Galileo Galilei stated that mathematics is the language with which God has written the universe, and AI is not magic, it's just mathematics. Depending on how an AI learns and applies the learning capabilities to process data, respond to stimuli, and interact with its environment, all AI can be broken down into the two categories: capability-based and functionality-based AI. Artificial narrow intelligence carries out very specific actions and has one cognitive capability without any learning skill beyond its design. Good examples of narrow intelligence are natural language processing, image recognition software, self-driving cars, and virtual assistants, as they cannot perform other tasks beyond that. Artificial general intelligence is built from technologies such as supercomputers, quantum hardware, and generative AI models like ChatGPT. General AI models are capable to learn, think, and perform multifunctional tasks and a wide range of actions similar to humans. Artificial superintelligence addresses science fiction and evolves from the general intelligence. It learns at the fastest rate and outperforms human capabilities. Reactive machines are the most basic variety of AI. They immediately respond back to a limited combination of inputs in real time. They are not capable of learning from past experiences as they do not possess memory and therefore are unable to interact with the world. Reactive machines respond in the exact same way every time they are presented with the same situation. Good examples are memoryless spam filters and all kinds of combinational logic units. All present-day AI systems are trained by large volumes of training data that they store in their memory to form a reference model for solving future problems. This type of AI is referred to as limited memory AI because it builds in its own limited knowledge base and improves it over time. Good examples of limited memory AI are finite state machines and self-driving cars, observing other cars on the road for their speed, direction, and proximity. In psychology, theory of mind refers to the capacity to understand other people, including beliefs, desires, intentions, emotions, etc. Theory of mind AI is implemented with a machine learning system. Computers embedded with the theory of mind are able to infer the objectives of entities around them. Robots of theory of mind AI systems communicate with human beings and are capable to understand the intention of other similar robots or systems equipped with theory of mind. It is believed conscious machines that can think independently and experience emotions the same as human beings can be successfully integrated in human society. Self-aware systems can form representations of themselves. This would be machines that know their internal states and are at the stage beyond the theory of mind and therefore may be out of our control because they will have a sense of self as well. This does not mean the end of humans and the end of humans' work. Constructing and deploying self-aware intellectual machines requires investing huge capacity of human permanently evolving experience and knowledge. There are other related types of AI. Analytical AI typically refers to the process of identifying, interpreting, and communicating meaningful patterns of data. It aims to discover new insights and relationships or dependencies in data and to assist in decision-making. Functional AI also explores massive quantities of data to execute actions rather than making recommendations. For instance, a functional AI model could be useful in robotics and IoT applications to take immediate actions. Interactive AI typically enables automation of interactive communication, for instance, to build chatbots and smart personal assistants. For building an interactive AI model, a variety of techniques such as machine learning, frequent pattern mining, reasoning, and AI heuristic search can be employed. Textual AI typically covers textual analytics or natural language processing, through which businesses can implement text recognition, speech-to-text conversion, machine translation, as well as content generation capabilities. Virtual AI is often used in fields such as computer vision and augmented reality. It is capable to recognize and classify items as well as converting images and videos into text like humans do. AI is highly dependent on the theories of mathematics. Among all these listed, machine learning plays a crucial role in AI. Basic needs of AI involve three main things. First, we need to know programming in any language. Python is preferred. Second, we should be good at math, propositional and higher order logic, algorithm design, and evaluation of algorithmic complexity. Third, we need to have comprehensive knowledge of the domain and the problem we are solving. There is a kind of methodology in software engineering, adaptive software development. This enables teams to quickly and effectively adapt to changing requirements or market needs by evolving their products with continuous learning. The adaptive approach encourages teams to develop according to a three-phase process: speculate, collaborate, and learn. IT companies range from small to mid-size and larger. Low-level companies offer the most basic IT services, whereas high-level companies offer all the basics with more specialized services included. Independent of the range, AI can support three important business needs: automating business processes, gaining insight through data analysis, and engaging with customers and employees. AI doesn't always perform best on its own. Businesses often achieve the greatest performance improvements when humans and machines work together. So we consider AI as a means of augmenting rather than replacing human capabilities. Despite the promise of AI, surveys in the area show that only a small percentage of companies engage adoption of AI. Most of companies apply AI in just a single business process. The main cause here is the absence of willingness to rewire the organization. AI initiatives face cultural and organizational barriers. Most businesses aren't born digital and have no willingness to change traditional mindsets and ways of working. To scale up AI, companies must make definite shifts. Shifting to AI is not an event, but a time and resource-consuming process. There are no strict guidelines and algorithmic steps to make the shift to AI. However, some recommendations, including a shift in mindset, has to happen in order to promote AI reaching its full potential. The first step is identification and segregation of machine work from human work. Most of the work we do today involves interactions with computers and machines. Idea of separating human work from machine work means designing and executing the work with different timelines for the people and the machines involved. This approach will significantly minimize tedious data preparation, integration, and data analysis, as many of these tasks will be automated. The second step is the acceleration of AI adoption to remain both relevant and competitive. Humans are notoriously resistant to change, and often for good reason. But AI evolution is very fast, and thinking AI won't come to some industry is a naive interpretation nowadays. Successful adoption of AI relies on cross-functional teams, from experts to technical contributors and validators, such as business users and product managers, software engineers, data scientists, testers, architects need to be involved to leverage AI faster and make AI the center of the business. Models are typically designed by data scientists in ideal conditions. Collaboration of domain experts, data scientists, and DevOps will allow the joint team to develop realistic plans for business process automation and management. AI suggests shifting from experience-based and leader-driven decision-making to data-driven decision-making. The concept of being data-driven refers to using data and facts to find patterns, inferences, and insights to help in decision-making. Essentially, data-driven prevents making decisions without bias or emotion and ensure that the company's goals and roadmap are based on evidence. And especially if you are in a leadership position, making objective decisions is the best way to remain confident. Corporate leaders and top executives represent a major level for this change. Before planning the shifting to AI, company leaders need to outline the business vision for the future. Unlike a mission statement, which defines where the company should be successful, the business vision represents how potential customers will respond when they have access to the company's products and services. For this purpose, the company should bring the goals and the strategy together, which is known to be the most challenging step. Once the company goal is identified, the company should collect and organize data. The data should be well structured to enable proper and efficient analysis and visualization. If you cannot see all relevant data in one place or in all levels of the data storage, or we skip discovering the data relations, then it will be difficult to ensure the appropriateness or weaknesses of the decisions made. The conclusions made over the analysis performed will adjust and address the business needs. We are slowly transitioning from a world with people and papers to software and data. Big technological companies use billions of data to analyze the needs of their customers and provide services accordingly. Let me see how AI empowers business management, business data analytics, software engineering, cybersecurity, and fraud detection. With the help of AI in business management, managers can predict future trends, forecast profits, and make better decisions, which will be of another quality, data-driven decision-making. Besides the listed capabilities, AI helps automating financial reporting, budgeting, and forecasting. Humans might be transitioning toward a day when it will be challenging for humans to work without the help of machines. There is an opinion that as a consequence, human reasoning and mental facilities may deprecate with time. We will argue with, because leveraging AI requires a significant knowledge base and skills such that schools and universities will be always places where humans get evolved. With ever-growing knowledge and technologies, nowadays scientists and developers outperform ancient philosophers and engineers. Future professionals will be even more knowledgeable. We will see that AI creates new jobs: data analysts, scientists, fundamental and experimental scientists, macro and micro world physicists, AI and machine learning specialists, digital and marketing strategists will be in high demand, and many other related jobs will emerge with time. Business runs on definite departments like wheels. These departments can be empowered with AI tools and technologies, provided competent analytics, data scientists, and developers. For example, AI can help onboarding new hires by automating the verification of employee documents, handling administrative tasks like providing individual cards to access to company hardware and software, etc. Machine learning algorithms are widely applied in financial data analysis. They can automatically learn from historical data, identify patterns, and make predictions or classifications. Techniques such as regression, decision trees, random forest, and support vector machines can be applied in risk assessment, fraud detection, market trend analysis, and portfolio optimization. Deep learning algorithms such as convolutional neural networks and recurrent neural networks are capable of handling complex financial data, such as images, time series data, and sequences. Data mining techniques discover hidden patterns and relationships within large data sets to identify customer segmentation, detect market trends, find correlated financial indicators, and discover abnormal behavior or fraud patterns. Predictive analytics can be involved to make predictions about future outcomes and can provide insights into stock prices, customer behavior, loan defaults, market trends, and other financial predictions. AI algorithms can help extract data from multiple sources, such as accounting software, spreadsheets, databases, and aggregate it into a centralized system. This eliminates the need for manual data entry and reduces the chances of errors or inconsistencies. An AI tool can support in automatically cleaning and validating financial data by identifying and correcting errors or missing values. This ensures the accuracy and data integrity during generating the reports, based on predefined templates and formats without human intervention. Anomaly detection can be achieved by analyzing large volumes of financial data, detecting patterns that may indicate fraudulent behavior. By establishing baseline patterns and comparing new data against them, AI-powered systems can identify suspicious transactions, unusual spending patterns, or discrepancies that will be subject for further investigation and legal proceedings. Employees already use various methods for monitoring employees for a number of reasons. Checking up on appropriate email, internet, and use of corporate resources mostly stops and blockades espionage and malware intrusion. There is no doubt that such strategic governance can be well deployed with the help of AI technologies. Employers will adopt the data protection principles in compliance with human rights, corporate professional ethics, and legal policy set out in the European Union General Data Protection Regulation, GDPR, to be relevant to monitoring employees, analyzing, and potentially acting on the results. An employer will need to ensure that monitoring is carried out for a specific, legitimate, and identifiable reason, and no other. No more information is gathered from the specified purpose than is necessary. Also, privacy of the staff and the information gathered through monitoring will be preserved. We believe no humans are capable to provide such a comprehensive inspection. Organizations can implement AI learning and development functions to identify knowledge gaps. Having diplomas in hand indicating the knowledge, skills, and competencies of graduates. Anyway, IT companies spend significant training time and resources to adapt the employees to corporate needs. Holistic teaching methodology with the same course materials for all employees is an old approach, as not all employees are the same. AI can be used to firstly assess and measure learner performance and skills and the corporate knowledge gaps. Once the gap is identified, automated tools can be applied such that each learner will get the most appropriate content. This approach saves the supervisor's energy and the learner's time, as they don't have to manually go through multiple web pages and filter irrelevant content. AI through natural language processing can even convert videos, webinars, and lectures into text. Compared with group leaders or supervisors, which are available according to some strict schedule, AI is a 24/7 tutor. It can personalize learning according to the pace, age, gender, and demographics of the learner. AI can release materials to the employee gradually as they successfully complete current units. Advanced topics will be downloaded solely after evidencing an acceptable threshold of required competence. This approach ensures distinct feedback, corporate academic integrity, and honesty in assessment. Also, it eliminates the need for a human trainer to some extent. Compared to other industrial and technological domains, which are mostly resistant to changes and innovations, software development is a career field that most intensively adopts AI. Developers are using AI, machine learning, and neural networks to automate manual tasks and permanently evolve their products. Generative AI models create new content, including text, images, audio, and video based on patterns it has learned from existing content. Auto-completion is another facility when, for example, our cell phone or Gmail suggests what the remainder of the word or sentence we are typing might be. It is a low-level form of generative AI. OpenAI is an AI research and development company dedicated to developing artificial general intelligence. ChatGPT is an AI-powered language model developed by OpenAI, capable of generating human-like text based on context and past conversations. DALL-E is another generative AI model developed by OpenAI. It can create realistic images and art from a description in natural language. AI can be applied to virtually any programming language. Popular languages like C++, Python, Java have embedded AI libraries and tools. Generative AI tools are successfully integrated into Visual Studio and other integrated development environments. IntelliSense is a well-known code completion aid that includes a number of features like list members, parameter info, quick info, and complete word. These features help programmers to learn more about the code they are using, keep track of the parameters they are introducing and processing, add calls to definitions, properties, and methods with only a few keystrokes. AI-equipped data analytics is a subset of business intelligence that uses machine learning techniques to discover insights, find new patterns, and discover relationships in data. In practice, AI analytics is the process of automating much of the work that a data analyst would traditionally perform. The goal is certainly not to replace analysts. Rather, AI analytics often improves the data analyst's capabilities in terms of speed and the scale of data that have to be analyzed, and the granularity of the data that can be monitored. Data scientists use math as well as coding to create and understand analytics. Linear algebra is used for working with vectors and matrices. Descriptive statistics are brief information coefficients like the mean, median, mode, standard deviation, variance, minimum and maximum variables. Probability is used to investigate random events. Inferential statistics uses statistical techniques to extrapolate information from a smaller sample to make predictions and draw conclusions about a larger population. It also performs regression analysis on tests such as z-test, null hypothesis, and alternate hypothesis testing. Differential calculus in business is applied to determine how different factors will affect supplier demand in the economic market. Necessity of coding is quite obvious. It is strongly recommended not to involve programmers having no acceptable background in math. The quality of data and analytics outcomes with AI technology is dependent on the quality of the data we use. It is important to filter, clean, and prepare data for optimal AI processing. It is still a good idea to organize the data, remove erroneous data, and make other decisions about what data is useful to end goals. Another good idea is to determine key performance indicators and use cases before getting started. The following questions mostly help to set the right goals for organizations who are the users which will be using the data analytics tool. Based on the company domain, data analytics may be more generic or industry specific with a particular compliance regulation. Determine the departments which will use the tool and to whom the outcomes will be presented. Should results be displayed in a certain dashboard or visualization format, or how frequently the results need to be presented, or what is the percentage of accuracy that is anticipated to achieve with data analysis results. To make data analysis appropriate, it is recommended to implement principles defined in data governance, which is everything we do to ensure data is secure, private, accurate, available, and usable. It includes the actions people must take, the processes they must follow, and the technology that supports them throughout the data lifecycle. The following are right tools that combine generative AI with advanced data analytics. Selection of data analytics tools that integrate VI models is an important factor. The most efficient way is to deploy data analytics platforms that already has been built-in generative AI capabilities. This will help users to automate, streamline, and grow their data analytics operations. AI helps in predictive modeling, which is a technique to predict the system future behavior. With segmentation analysis, AI models can be trained and deployed by automatically analyze data sets and do sentiment analysis. The three main types of firewalls, such as packet filtering, stateful inspection, and proxy, offer advanced protection levels from network external threats. Network sniffers, also known as packet analyzers, are either software or hardware that can intercept data packets as they travel across a network. Admins use network sniffers to monitor network traffic at the packet level, helping ensure network health and security. APT attacks are sophisticated, sustained cyber attacks in which an intruder establishes an undetected presence in a network in order to steal sensitive data over a prolonged period of time. Famous APT attacks examples are GhostNet based in China. Attacks were conducted by spear phishing emails containing malware. Spear phishing attacks target a specific victim, and messages are modified to specifically address that victim, purportedly coming from an entity that they are familiar with and containing personal information. Spear phishing requires more intelligence and time to achieve than traditional phishing. Stuxnet was a worm used to attack Iran's nuclear program, which was delivered by an infected USB device and inflicted damage to centrifuges used to enrich uranium. APT attacks have multiple stages, from initial access by attackers to ultimate exfiltration of the data and follow-on attacks. APT groups start their campaign by gaining access to a network via one of three attack surfaces: web-based systems, networks, or human users. They typically achieve access via malicious uploads, searching for and exploiting application vulnerabilities, gaps in security tools, and most commonly, spear phishing, targeting employees with privileged accounts. The goal is to infect the target with malicious software. After they gain access, attackers compromise the penetrated system by installing a backdoor shell, a malware as legitimate software that allows them network access and remote control of the penetrated system. An important milestone is to establish an unbound connection to their command and control system. APTs may use advanced malware techniques such as encryption, obfuscation, or code rewriting to hide their activity. Attackers use the forced penetration to gather more information about the target network. Once they have expanded their presence, attackers identify the data or assets they are after and transfer it to a secure location inside the network, typically encrypted and compressed to prepare for exfiltration. This stage can take time as attackers continue to compromise more sensitive systems and transfer their data to secure storage. Up to date, there is no any technological defense tool to detect and block APT attacks. Undoubtedly, no human staff can afford it. The only remedy is to embed AI-based intrusion detection and prevention systems, which will fully inspect every node, every data flow and traffic inside the network. Anomaly detection is one of the most common approaches in AI cyber defense. Finding and identifying outliers helps to prevent fraud, adversary attacks, and network intrusions that can compromise the company's future. For example, when a data point is detected to have value for far outside the range, meanwhile all the other data point value ranges in the data set, it can be considered a global anomaly. Outliers may be contextual. This means that its value doesn't correspond with what we expect to observe for a similar data point in the same context. Collective outliers are represented by a subset of data points that deviate from the normal behavior. If you imagine detecting anomalies in huge amount of data, such as transactions, text, images, video contents, network traffic, it means spending days going through all the transitions that happen inside the company every hour, and more are generated every second. We believe it is impossible to derive any meaningful insights from this amount of data manually. Moreover, another difficulty is that the data is often unstructured. For example, business documents, emails, or images are not arranged in any order. AI algorithms are able to process any types of data of any volume. By involving machine learning algorithms, AI can detect anomalies. Local outlier factor is the most common technique for anomaly detection. It compares the local density of an object with that of its neighboring data points. If a data point has a lower density than its neighbors, then it is considered an outlier. Key nearest neighbors is a supervised machine learning algorithm often used for classification, but when applied to anomaly detection problems, it is a useful tool because it allows to easily visualize the data points and make anomaly detection much more intuitive. Support vector machines are also supervised machine learning algorithms often used for classification. It uses hyperplanes in multidimensional space to divide the data points into classes. The model is trained to learn the so-called norm and can identify whether unfamiliar data belongs to this class or represents an anomaly. DBSCAN is an unsupervised ML algorithm based on the principle of density. The points that do not belong to any cluster get their own class, so they can be localized and investigated. Autoencoder's algorithm is based on the use of artificial neural networks that encode the data by compressing it into the lower dimensions. Then data is decoded to reconstruct the original input. As the rules have already been identified in the compressed data, no necessary information will be lost and the outliers will be discovered. Bayesian networks are able to discover anomalies even in high dimensional data. Concerned with fraud detection, traditional systems are becoming less effective in detecting fraud with the increasing number of financial transactions happening online. AI-powered fraud detection systems are using machine learning algorithms to analyze a vast amount of data in real time, identifying patterns and anomalies. These systems are trained on historical data, improving their accuracy and effectiveness over time. By analyzing transactional data, customer behavior, and other relevant factors, AI systems can identify potential fraud indicators and trigger preventive actions in real time. These actions may include activating verification measures, blocking suspicious transactions, or notifying the relevant authorities. Facial recognition is another successful application for identifying criminals and troublemakers. Evolution of AI, like evolution of humanity, will change most of things around us. For users, AI-powered solutions will seem to be magic. Meanwhile, designers and developers will put a lot of efforts to scale AI in organizations. That's all for today. Thanks for watching. I wish you a great success. Goodbye.